Building production-ready research agents with LangGraph, X a case study. The introduction, the challenge of deep research at scale. When X has set out to build a production-ready deep research agent, they face the same challenge many organizations encounter. How do you create an AI system that can handle complex multi-step research tasks while maintaining reliability, observability, and cost efficiency? Their solution, built with LangGraph, represents a masterclass in multi-agent architecture design. Let's break down exactly how they built this system and what makes it so effective. The architecture, a multi-agent symphony. The diagram shows X's sophisticated multi-agent workflow designed around three core principles: snippet-first reasoning, structured output, and production observability. Let's walk through each component. The planner, the brain of the operation. Responsibilities: get full context of the research query, break down complex questions into manageable subtasks, plan the research strategy. X's innovation, snippet-first reasoning. Instead of immediately fetching full web pages, expensive in tokens, the planner first works with search snippets. This approach reduces token consumption by 60 to 80%, speeds up initial analysis, allows for broader search coverage, only fetches full content when truly necessary. LangChain implementation, Python class research planner base model, define plan research self.query string, list.research tasks. Analyze query complexity, generate search strategies, create task breakdown, record reasoning for observability. The task execution layer, parallel processing power. The multitask architecture. The planner spawns multiple parallel tasks, each with specific instructions tailored to the subtask, defined output format ensuring consistency, targeted search scope, optimizing for relevance. Why this matters? Parallel execution dramatically reduces total research time. Each task can be optimized for its specific domain. Failures in one task don't crash the entire research process. Results can be cached and reused across similar queries. Production insight. X's system can handle research queries that would traditionally require hours of human work, completing them in minutes through intelligent parallelization. The observer, quality control and decision-making. The critical checkpoint. The observer serves as the system's quality control, asking the crucial question: are we ready to produce the final output? Key responsibilities: evaluate completeness of gathered information, identify gaps in research coverage, decide whether additional tasks are needed, maintain research quality standards. X's quality metrics. Coverage. Do we have information on all aspects of the query? Depth. Is the information sufficiently detailed? Reliability. Are sources credible and current? Coherence. Can we synthesize a meaningful response? The decision loop. No, loop back to planner for additional tasks. Yes, proceed to draft generation. This iterative approach ensures thoroughness while preventing infinite loops through intelligent stopping criteria. The context management system, memory and reasoning. The persistent memory. The dotted box on the right represents X's context management system, which includes all planning or reasoning steps for full transparency, all task outputs for comprehensive synthesis, all citations and sources for credibility. LangSmith integration. X uses LangSmith for production observability, tracking token use per component, caching effectiveness, performance bottlenecks, and quality metrics. Why this matters? Full auditability of research process, cost optimization through usage tracking, performance optimization through bottleneck identification, quality assurance through reasoning transparency. The draft report, structured synthesis, intelligent aggregation. The draft report component doesn't just concatenate results. It synthesizes information from multiple sources, identifies contradictions and reconciles them, structures information logically, and maintains source attribution. Structured JSON output. X enforces schema compliance through structured output, ensuring consistent response format, reliable API integration, easy post-processing, and automated quality validation. The writer. Coherence and finalization. The final polish. The writer component focuses on ensuring coherent narrative flow, maintaining consistent tone and style, optimizing for target audience, and final quality assurance. Production considerations: style templates for different use cases, tone adjustment based on query type, length optimization based on requirements, citation formatting and verification. LangGraph implementation, the technical foundation. State management, Python class research state, typed dict query string, tasks list, research tasks, results list task results, context research context, draft optional string, final output optional string. Node definition, Python, define create research graph, workflow equals state graph, research state, add nodes, workflow.addNode planner, planner node, workflow.addNode task executor node, workflow.addNode observer, observer node, workflow.addNode draft writer node, workflow.addNode final writer node. Define edges and conditions, workflow.add conditional edges observer, should continue planner, finish, draft writer. Conditional logic, Python, define should continue state research state, string evaluate research completeness, check quality thresholds, determine next action. If research complete state, return, finish, return, continue. Production insights, what makes the system scale? 1. Cost optimization through snippet first approach. Problem, full web page processing is token expensive. Solution, start with search snippets and escalate to full content only when needed. Result, 60 to 80% reduction in token costs. 2. Reliability through structured output. Problem: unstructured LMM outputs are hard to integrate. Solution: schema and force JSON responses. Result: consistent, reliable API responses. 3. Observability through LangSmith integration. Problem: production AI systems are black boxes. Solution: comprehensive logging and monitoring. Result: optimizable, debuggable, scalable system. 4. Quality through multi-agent validation. Problem: single agent systems lack quality control. Solution: observer agent validates completeness. Result: higher quality, more reliable outputs. Real-world applications: business intelligence, market research and competitive analysis, industry trend identification, regulatory compliance research, academic research, literature reviews and synthesis, cross-disciplinary research, hypothesis generation and validation, legal research, case law analysis, regulatory research, due diligence investigations, technical research, technology landscape analysis, best practice identification, architecture decision research, implementation roadmap. Phase 1, basic multi-agent setup. Implement planner, task, observer flow. Add basic context management, create simple output formatting. Phase 2, production hardening. Add LangSmith integration, implement snippet first reasoning, add structured output validation. Phase 3, advanced features, implement intelligent caching, add quality scoring mechanisms, create specialized task types. Phase 4, scale optimization, optimize for cost and speed, add advanced monitoring, implement A/B testing framework. Key takeaways for your implementation. 1. Start with clear architecture. Define your agent's roles clearly before implementation. Each agent should have a specific, well-defined responsibility. 2. Implement observability early. LangSmith integration isn't optional for production systems. It's essential for optimization and debugging. 3. Use structured output. Schema enforcement prevents integration headaches and ensures consistent behavior. 4. Optimize for token efficiency. Snippet first reasoning and intelligent content fetching can dramatically reduce costs. 5. Building quality controls. The observer pattern ensures your system maintains quality standards automatically. The future of research agents. X's implementation demonstrates that production-ready AI research agents aren't just possible, they're here. By combining LangGraph's orchestration capabilities with thoughtful architecture design, they've created a system that handles complex research tasks autonomously, maintains production-grade reliability, operates cost-effectively at scale, provides full observability and control. This represents the future of AI-powered research, not replacing human researchers, but augmenting their capabilities with intelligent, scalable, and reliable automation. The blueprint is clear, the tools are available. The question is, what will you research next?